episode 30 today, and if you would have told me 29 episodes ago that we were going to make it to 30, I would say
is that why?
Absolutely, because we are driven, and we.
Is that what makes it special? Why is it a special episode?
I just like the round.
No,
okay.
10,
so
didn't know why it was special. I mean, it's special because we have Tom here, but outside of that, why?
No,
Okay.
It's actually exciting because today we do have Tom Dower. He's the Vice President of Public Policy for LanzaTech, and why I'm excited is because 2 episodes ago, Jeff and I had the European CO2 Summit. We posted that, and we talked about how important it is to start looking at some of the users of CO2. One of those companies that we are somewhat enamored with, we think they're doing big things, is LanzaTech. And so today we're going to learn about them, their technology, and everything exciting that's going on. So Tom, welcome to the show. Welcome to special episode 30.
Special episode.
Thank you. Thanks, Luke. Thanks, Jeff. It's great to be here. Great to have this conversation.
Yeah, no, I've been looking forward to this one. You and I met a few months back. I first came across LanzaTech, I don't know, maybe 6-7 months ago, and I was fascinated. And as I said in my original communications with the team, I'm stealing. You didn't trademark my new saying, so I stole it and trademarked it. But I'm all about utilization of CO2, not just sequestration. And I used to say, we need more U in CCUS. And I think it was your CEO, Jennifer, or maybe it was Freya, that said the U is silent in CCUS. And so I use that all the time now. So I have now trademarked that. So totally appreciate it. No royalties back to you whatsoever. Yeah, no, it's I can't wait to get into this a little bit and understand what LanzaTech is doing, the technology, the IP that you have. But I see this as such a, if it becomes scalable, which it seems like it is, and we want to hear your inputs on that. But this is a game changer for, activating a circular economy, getting off of fossil fuels without having to replace everything else that we do in the world. So, when I heard the story of LanzaTech, it just kind of just like tied into how I view how we get off of fossil fuels long term. And I always like to say it's not, we need to get off of the term decarbonization, because the carbon's not the problem. It's the fossil fuel pulling that's the problem. Solve for that. We still need all these other materials, and you guys have a solution for that. So, great to have you on. Great to see you again. And why don't we just dive right in? What is LanzaTech? What do you guys? What's your product? What's your market? And then we'll kind of talk through some of the other aspects.
Yeah, that sounds great. And it sounds like if you ever need another job, I know exactly the company that you could come to. Because you are definitely speaking our language, Jeff.
Well, I think we determined you and I are from a same genetic makeup somewhere. It's not just the bald head. It's it's
definitely. Well, yeah,
doesn't hurt, but yeah, male pattern baldness does run in the family. But
great,
I'm on my way. That's what
you are absolutely, but you and I are not related. So when you're bald, you're just bald.
Well, that was my point. Is great opening. It's exactly the kind of stuff that we think about as a company. So I'm really proud to be a part of the LanzaTech family, the LanzaTech team. So we, as a company, we've been around since 2005. We were actually founded in New Zealand by really smart scientists working on synthetic biology, and I could talk about all of the sort of science side of it, even with my political science background. But now, as a company, we've really insourced into the U.S. over the years. So we're now a U.S.-based company. As of last year, we're actually traded on the NASDAQ as LNZA. So we're a publicly facing company, publicly traded company. And at the heart of what we do is really biorecycling. So LanzaTech captures and processes multiple forms of waste carbon before they can enter the atmosphere or the environment and cause harm. So emission sources like steel mills and landfill sites can attach essentially LanzaTech's bioreactors to their facilities, which then act similar to a brewery. And what we're doing here is called gas fermentation. But instead of using yeast to convert sugar into beer or alcohol, our proprietary microbes convert carbon-rich gases into essential raw materials like ethanol, which can be a primary ingredient of fuels and a range of everyday consumer goods. And this process allows LanzaTech to really create value from waste. And we could get into some of those waste streams, but it's really a very wide array of what we would call feedstocks or our raw materials, and feeding them to biology to produce that whole range of chemicals and fuels that, as you said, Jeff, still require carbon as a central molecule. So it really is about defossilization, not decarbonization for those products. even after we've hit our targets, as a society for what people do call decarbonization as much as possible, there's still going to be quite a swath of products that require carbon, and we're here to make sure that we source that carbon from above ground waste.
Yeah, no, that's I love that way of putting it. And I look at we talk to a lot and work with a lot of direct air capture companies, and I'm not the biggest advocate of DAC, but I also understand there's a need for it, but I'm also concerned about the scalability of it long term. And I look at DAC as, look, there's this existing a glut of CO2 in our atmosphere that we have to remove. But after that, let's just say we could remove it in the next 20 years and get us back to pre-industrial ages, assuming we don't generate any more CO2, but we are going to generate more CO2. We continue to add more. So even if we remove everything to get us back to point zero, we still are adding to it every single day. So and most of that is coming from hard-to-abate industries. And to me, it's like, capture it at the source of production, off a steel mill, off of power generation, off of buildings. Those three items right there make up more than 50% of all of our carbon emissions globally. Then you add in landfills and things like that. You got a whole nother 10, 15% in there. Cars and automobiles and transportation sector isn't the biggest problem we have, but it's the one that gets all the news from where we're generating the CO2. But the problem is there's no real good scalable technology today to capture off of a power generating facility, and then what do you do with that CO2 after you do it? And if we're just sequestering it, well, then what? That never goes away either. So you are capturing off of hard to abate producers of CO2 that we need for the next 50, 100 years minimum. We need those. We're going to always produce power. We're going to make steel, all these things. But then are you able to boil that down to its raw components and fundamental materials and molecules of the world of everything that we can build, and using it for good things? So, yeah, I don't think there was a question in there. That was my soapbox.
Let me jump in if you
don't mind. That was my soapbox. Yes. Oh, how do you feel about that?
Kind of along those lines, right? Is I think we're going to move into pretty quickly in this conversation. What are those products? And
yes.
What are the uses? Before we jump to Jeff's point, hard-to-abate industries, the CO2 composition within a steel mill is quite different from that of a biogenic source like a landfill. So, Tom, you had noted, we take CO2-rich streams off gas and we can convert. What is the variation there? It sounds like you can really play in any sort of emission, but is it special filtration on the front? How do we get to a place where you're able to implement that brewery process to create the ethanol?
Yeah. Oh, that great question, Luke. So, first of all, the way our biology works, and this bacteria we're using, which is a Clostridium strain, it's Clostridium autoethanogenum, or C. auto for short. I'm
gonna go with that.
Yeah, these are words to remember. It really wants to consume carbon and energy. So the first source that it looks to is actually carbon monoxide. So in terms of sort of low-hanging fruit of feedstocks, it wants gas and it wants carbon and energy. So if we can find carbon monoxide intensive off gases from steel mills, from silicon carbide, from any industrial processes that have either incomplete combustion or other reasons for producing carbon monoxide, which you then have to do something with, right? You can't just release CO into the atmosphere, and it has energy content. So it's a really great high efficiency use of that waste carbon before it's converted essentially to carbon dioxide prior to going to the atmosphere. So that's really the very low hanging fruit. And so we can get various compositions of gases that have CO. And then if we give our organism carbon dioxide, that's an inert compound. It doesn't give anybody any energy because it doesn't have any. We have to add hydrogen. And so we want clean, low carbon hydrogen to allow the uptake of that carbon dioxide in the product through this biology. So the neat thing about using biology versus some thermochemical processes is those compositions really can vary. And so, it's really a question of what size unit, how much throughput do you have, what are the volumes and compositions of those gases that are available, which then gets down to economics and sort of Jeff alluded to this earlier, but the scalability of the technology. And that's where LanzaTech has been able to take a technology that is known, but hadn't really scaled. And so what we've been able to do over these past several years is really take it to commercial industrial scale biotechnology, which has been a real challenge for many others. There have been startups in biotech, and sometimes it's really hard to get over that so-called valley of death between the lab and some pilots and demos and getting that to really something that's commercially scalable. So we're able to take those varying compositions and feed it to our bacteria, which then just uses the available carbon and energy. And if you have other things in there, or if you have too much CO2, for example, those gases can just pass through. It doesn't have to deal with every molecule, which is another neat thing about it. And then, by the way, at the end of life, this is a living organism, right? So it also has an end of life, and it turns out to be very high protein. So in terms of utilization and circular economy, Jeff, you'll love the fact that we also get a protein product out of this whole process. So we're getting a chemical or a fuel, but then we're also getting a protein that could be used in aquaculture or in feed for chickens or other animals, et cetera. So it's a pretty holistic approach, and just like nature, using everything that we can to produce those products.
That's great. So where are you in the life cycle? So I know you've got some pilot programs, you've done a multitude of lab environments and proof of concepts, but where are you in the life cycle of scalability and active projects?
Yeah, so basically our first commercial scale project actually goes back to 2018. So and it's continuously operating, and it's on the back end of a steel mill. And I will say we are definitely focused on hard-to-abate sectors. And actually, LanzaTech really believes that the power sector has a lot of options, has a lot of choices. So we have not been pursuing power plant projects, but we are on steel mills, ferroalloy mills. So some of the alloys that are added to iron and steel to give them the chemical compositions that they need to meet really exacting properties of automakers and others who use steel in the economy. We are working with refineries like the Indian Oil Refinery. It's a project that's coming online in Panipat, India. And so right now we have 4 steel mill and ferroalloy mills in China. We have the ArcelorMittal Ghent facility in Belgium, commercial scale steel mill project, and then this Indian Oil Refinery project. So we've been able to deploy in multiple continents and at commercial scale. So those are the 6 facilities, 2 of which are currently in startup, but mechanically complete. And so we've really been able to show you can definitely take this technology from lab, from pilot, through demo, and then into full commercial application. And what we want to do, and we're trying to do with various partners in various places, including in the U.S., is deploy on more types of feedstocks, different types of gases, different industries that we can help both decarbonize and provide a value source for them, where we're taking what is normally a waste and all cost and turning that almost in a judo move, right? Carbon is our problem. If we take it and really drive it into value, then we can hopefully drive further emissions where they need to go.
That kind of tees up my question, understanding the business model. So you have a technology, it sounds like that technology is licensed. Are you taking the raw gas stream, and that is, that's where the line is drawn between the people you partner with in different industries and where your product is, or are they licensing it and selling you the chemical that is produced? What does this look like? Does it change by industry? Does it change by volume?
So our model currently with the projects that I've been talking about is essentially the facilities that have these emissions, right? They have the gases, they own them, and in fact, it's their problem to solve, right? And depending on where they are, they have more or less pressure to solve that, either through direct regulation or pressure from investors, consumers of their products, their customers down the line. And so they have those gases. We are licensing our bioreactors and our bioreactor technology to help them convert those gases. So we work with them to design facilities, a bioreactor that we sort of put on the back end of their process, of their emission stack. and they will own those and operate those facilities, and then they will get product out of that, whether that's ethanol or other chemicals like isopropanol or acetone. So they will actually own all of that, and then it's just a matter of contract of whether they will work to sell that product into the market, or they will let us have some of that offtake, and we go ahead and market that with many of our customers. We've gone down the line, down the supply chains to quite a number of really interesting brands and products. We can talk about that a little later, but there's sort of a mixture of roles that we can play and they can play, and then in the end, we could also, we're working with other partners like Brookfield Renewables, which has committed about $500 million to help deploy LanzaTech projects. We would essentially work with partners that have those feedstocks, take the project down the commercial development chain down to FID, to the final investment decision, and then work with investors like Brookfield to build, own, operate those. And then someday, LanzaTech itself might be in the business of build, own, operate as well. But as a startup, and then as a new company on the stock exchange, we don't have a deep balance sheet to be financing $250 to $500 million projects ourselves. So we're always looking for partners to help us do that.
Yeah, that's great. So I got a 2-part question in all of this. The first one is, compared to alternatives, what whether any of those that you just mentioned, how's the cost competitiveness of the product itself? And then the second part of that question is, how reliant or non-reliant are you on government subsidies, programs, 45Q, things like that?
Yeah, so it really is going to depend on a number of factors, particularly regionally, is the way I like to think about it. Is in which country you are operating, what are you competing against, right? And I'm in the U.S., and so that's the primary market that I think about. We're in a place that doesn't have a price on carbon, right? And we are trying to replace products that are today made with essentially cheap fossil fuels because they don't have to account for the externality of all of the environmental harm that they're doing. We as society get to pay for that, lucky us. But to think that consumers aren't paying for it, we are. It's not directly ascribed to the price of that product on the front end. So competing directly head to head with virgin fossil fuels that have had a century to a century and a half of deployment of trillions of dollars of both public and private subsidies, it's virtually impossible to go head to head with them, with those products, absent some policy help, right? So that's the U.S. environment, and therefore the programs that are really meant to help scale technology, again, giving new technologies that opportunity to get down the cost curve, to get to the higher efficiencies of the processes, to get the supply chains in place, right? And particularly if we start talking about solid feedstocks, municipal solid waste, or agricultural or forestry residues, which could be gasified. Those are also within our suite of potential feedstocks. Each of those comes at a cost, and getting those whole supply chains set up is really a huge endeavor. So it is definitely difficult to compete on pure cost. But what we do find in the market is that's basically what consumers and when consumer-facing brands and others are really expecting ultimately of the clean economy. They want to be able to decarbonize their processes, but they also know that in many cases consumers are pretty fickle, and there's a lot of competition for their wallet, right? So the products that they want to sell, they do have to somehow keep it within a zone, and some are willing to pay what we call the green premium, which is the incremental cost of providing an alternative product that has a lower carbon footprint or a lower environmental footprint, more sustainability. There are some of our customers that have really been able to take that on. Some examples are, we're working with Coty, which is a fragrance manufacturer, and they've worked with Gucci to make some fragrances from our process, which is steel mill off gases through biology to ethanol to these downstream products. So very cool. Lululemon has been a longtime partner, making running shorts. We've been working with H&M Move a clothing line, Adidas on shoes, foam soles of running shoes, Zara dresses. So very accessible stuff that are in people's lives. People buy this stuff every day, and most people really don't think about all the supply chains that feed that. But those are all fossil based products for the most part, and replacing that with waste carbon is really what we're all about. And so our ability to do that in different markets is just going to depend. If we're talking about India, that's much more of a focus on bringing energy to the people, so much more focus on fuels and products that would hopefully back out their need to import oil and other raw materials, because they don't have the same oil and natural gas resources as some other regions. If we talk about Europe, then there's a lot more regulatory pressure as well. So it really kind of depends on where you are.
Yeah, so that's a great segue. Talk about some of these end uses, because that's the part that I think people don't really understand, in a general, broad public perspective of everything's made with fossil fuels. You can't just say, get rid of fossil fuels, or I'm driving an electric car now, so we don't need fossil fuels anymore, stop pumping oil. Everything in our environment, everything I'm looking at in this room, everything in the picture screen here is made from fossil fuel at some point. So, we have this process, you get it down to ethanol. What types of products, whether it's PET or whatever, what other chemicals, run down a list of things that your product ultimately
Okay,
can
well,
go
I'm
into.
sure I will miss some, but some of the things I was just talking about are textiles, polyethylene, the things that go into, stretchy materials, polyester, those sorts of things. So textiles, again, shoes, packaging, so plastics, PET, absolutely, MEG, the fragrances, cleaning products, detergents, surfactants, those sorts of things. We've been working with Unilever, for example, on clothing detergents, and then again, sort of packaging and containers themselves. So it's really this full swath, and the way I think about it is really talking about the chemical supply chain, and the fact that we can take carbon and hydrogen atoms and essentially put them into a whole diverse array of chemicals and products. And then a very important one as well. I mean, obviously, you already mentioned ethanol itself can be a drop-in fuel additive, right? And that's certainly something that is done heavily in the United States, in Brazil, in China, in India has growing needs for that as well. Again, that can substitute for some fraction of fossil fuels. But then sustainable aviation fuel. That's another sort of going to your opening, Jeff, on the sectors that are impacted. And if you add up all the emissions from each of those, we're talking about on the front end, steel emissions of 8 or 9%. The cement industry has a lot of CO2 emissions, around 8% globally. You add aviation, which is 2 to 3% globally and rising, because more people are traveling by aircraft. And they have very few options for decarbonization. So the fuel itself really provides we think about a 60% reduction option for aircraft. So you start adding all those sectors up, and then chemicals as well. I mean, you're really talking huge amounts of emissions to the atmosphere that can and should be avoided and have to be avoided. So using recycled carbon to do that just seems to make a lot of sense to us. So the products and uses are really just almost as wide as you can envision for the entire chemical industry. That all the needs that they are servicing, we can just replace the fossil input into that with waste carbon. And then one other point I'll make is that we also don't pull barrels of oil out of the ground for one specific purpose, right? And so if we never figure out a way to replace those carbon and hydrogen atoms from a barrel of oil for particular applications, hard to abate applications like chemicals, we're actually stuck continuously pulling new fossil out of the ground. Even if you transitioned the light duty vehicle fleet to electric vehicles, or if you transitioned maritime to renewable fuels or something else, you're still going to have to pull the barrel of oil out of the ground. And I was once talking to the CEO of Shell Oil, that you may have heard of, and when I was in the U.S. Senate, and he basically told me about cracking a barrel of oil, and it's like, you have to crack the whole barrel. You can't just crack a portion of it, right? So if we don't get around to replacing those essential carbon molecules, then we're actually going to probably delay the decarbonization, the defossilization of a number of industries, right? Because if you pull a barrel of oil out of the ground for one purpose, you'll then kind of have cheap options from the rest of the barrel that you've cracked, which delays, electrification for light duty vehicles, for example.
And you can't ask the world to change their behaviors
Right.
on everything we do. Like I say, you're not going to get
Yeah.
rid of steel mills. We need steel. We will always need steel. We will always need cement and concrete. Maybe always means 100+ years from now. No, okay, figure it out. But we're not going to figure it out anytime soon. So the best thing that we could do is start to chip away and minimize the demand for fossil fuels, and then it becomes too expensive to pump it. And now all of a sudden you don't have that cheap commodity. It's not cheap anymore. And everything else becomes lower cost and replaces those fossil fuels. And that's why, like I said, I think you said it too. I don't call it decarbonization because that puts the negative connotation on the carbon. Is defossilization by replacing those things with like you say, recycled CO2. That's
Yeah, and
that's how you
at a
get
high
to the
level, I'll
circular
also
economy.
just say, from a LanzaTech ethos perspective, at least, we also think that we should do everything else too. Like, we should be reducing our consumption to the extent possible, right? We don't need to use as much material as we do for everything that we do. We should also talk about substituting materials, where using the best material in the right application. And I used to work, full disclosure, I used to work in the steel industry, and steel is great and recyclable and all those things, but it's not going to be the perfect application of a material in every case. You really should weigh all the options, and then additionally, we should be designing for end of life. Right? Steel is very easy to recycle because it's magnetic. But once you get mixed materials, you get aluminum, you get graphite, you get all these other materials. We really should be designing for end of life for reuse, hopefully, because that's the lowest additional pressure on the environment, on sustainability of the planet. But then you mechanical recycling, recycle as much as we possibly can. But then what we offer is actually another option, particularly if we're talking about plastics and municipal solid waste and some of those mixed materials that are really hard to separate and therefore very difficult to directly recycle. Instead, they go to landfills. Is gasifying those and then converting those into the products that the economy still needs.
Yep. Nope.
Oh, that's well said. Let's focus on one in particular in deep dive, and that's the sustainable aviation fuel. So we know that LanzaTech spun off LanzaJet. Would love for you to kind of break down for us and the audience who LanzaJet is, why sustainable aviation fuel is the first focus of spin-off.
Yeah, happy to. It's actually really an incredible story. And it really gets to public-private partnerships and the importance of government work as well, which is the world I live in policy land. What LanzaTech did early on, and this is really truly credit to Dr. Jennifer Holmgren, our wonderful CEO, who is a pioneer on sustainable aviation fuel, just world renowned, and understood that our product of first resort is ethanol, which is an energy carrier, right? That's the way we think about it, an energy and carbon carrier. And as she noted, that there should be a way to take ethanol and convert it into aviation grade fuels. And so she started working with the U.S. Department of Energy. We worked closely with the Pacific Northwest National Lab. And over what amounted to be about 11 years or so, we worked to take from lab scale to really now commercial application, an alcohol to jet technology, which can take ethanol of any type, right? So LanzaTech makes ethanol, but we make it with certain feedstocks, and we don't make it with certain other ones. But it can actually take any kind of ethanol and convert it in a fairly simple 4-step process into aviation fuel, and we call that SAF, or sustainable aviation fuel. And the idea to spin off LanzaJet was that that's a huge market that could absolutely take the entire focus of an entire company, because aviation is one of those really difficult to decarbonize sectors, hard to abate, as we said earlier, and therefore really needs focus. And to the extent that these SAF fuels, of which there are several that have been approved through the governing bodies like ASTM standards, they right now are usually made with some pretty low-hanging fruit, like waste fats, oils, and greases, like French fry oil and that sort of thing, which is a great application of using waste oil. But there's only so many French fries that we all can eat, and only so much waste oil that's available. So
I don't know. I
We're
think the
trying.
Americans do pretty good. I mean, rest of the world
Yeah,
maybe not, but I
we're
think we do
doing our
pretty good
part,
here.
certainly on a per capita basis, myself included. So the question then is, well, what's the next generation of these aviation fuels? And really, this ability to convert ethanol into SAF is a huge opportunity, and it's one given the other transitions that are happening, like the light duty vehicle fleet, which is as it goes to electrification, it's going to be reducing the need for new liquid fuels transitioning those and the various waste-based ones that LanzaTech can do into SAF just is a huge opportunity for the aviation sector for jobs that could be placed all around the country and all around the world, and bringing that fuel production closer to where those airports are, and not relying on the traditional virgin fossil supply chain. So LanzaJet was spun out just a few years ago, and proud to report that together we've been working on this great project that LanzaJet just announced the mechanical completion of a 10 million gallon per year facility in Soperton, Georgia, in Troitland County, very rural area between Savannah and Atlanta, if you want to sort of envision where it is. And the beauty of this alcohol to jet technology is that it can actually take a a gallon of ethanol and can make a 90% conversion to aviation fuel, and then a 10% conversion to renewable diesel. Or in flip, if you wanted to, make renewable diesel, you could make 75% renewable diesel and 25% SAF. That is a really strong move towards moving those liquid transportation fuel molecules into the hardest to abate sector, into aviation. Whereas a lot of other technologies, they really they prioritize or want to make renewable diesel, and then you get a little bit of SAF. This is a real interesting way, and that's why the Department of Energy was so interested in that technology, because they really want to target those limited resources to the greatest need, which is aviation. So LanzaJet is up and running, their own company. They are a separate company, to be clear. We are an investor as a company. LanzaTech is invested in LanzaJet, and our CEO is chairman of the board. But otherwise, they're off to the running, trying to deploy projects all around the world. If you go to their website and check it out, there are lots of world flags, lots of countries really interested in deploying that technology, which can take advantage of their indigenous feedstocks.
Yeah, so yeah, in about a week and a half, I'm actually driving from Atlanta to Savannah, so
Perfect.
I'll reach out for a
That's
visitor's
great, and
pass.
you can visit the LanzaTech facility, which is right over the fence. We also that's actually where we have a scale-up facility for biorefinery, basically. So we're able to take what we do in the labs in Skokie, Illinois, north of Chicago, and then if we want to do that at the next biggest scale, we move that down to Georgia, where we have a great workforce, really committed people, very safe operations, and really excited about our work down there.
No, that's great. So, well, maybe we'll close on the most positive for you guys. Recent announcement of a grant from the Department of Energy. Why don't you kind of what's that all about? And that's got some
Yeah,
good
thank you.
funding
Thanks for
there.
asking.
What's
This
the
one's really
project?
exciting for us. So this was a $200 million conditional award with the Department of Energy with this new Office of Clean Energy Demonstrations, which has just been stood up in the last few years to implement the bipartisan infrastructure law funding, and then the Inflation Reduction Act funding. And what our project is partnering with an ethylene company, so Technip, which is a global leader in ethylene production, which is really important for a lot of those downstream applications that we were talking about earlier, because ethylene is a huge commodity in the chemical space and getting into fabrics and other important commodities. So we're working with them to actually take their CO2 stream. So they do have CO2 emissions. They're using fossil fuels to produce ethylene. They get CO2 emissions. We're going to capture those CO2 emissions and convert them through our biology-based system into ethanol and then back into ethylene. So for me, this is a really unique story, and it's what we're trying to do in multiple sectors, where we're able to take the carbon emissions from one process, convert those through our technology back into the same product they're trying to make. And so that is truly the circular economy in action. It's similar story to what we could do if we took the CO2 from ethanol plants, for example, and combine that with clean hydrogen, convert that back into ethanol, which, they lose about a third of their original carbon as CO2. If we can capture that and make more ethanol, that puts less pressure on the system to get them more raw materials, more corn, more soy, et cetera, to make that same material. So, and that's a way to really kind of get to power to liquids, which is using electrons, using clean energy to get there. And similar with this project with DOE and Technip to really get to that circular economy, clean electrons to make hydrogen, CO2 capture, and making the whole thing work for what consumers are using and what they need and will continue to need into the future.
Is that 200 million? Is that going to fund one singular location, or is there plans to, branch?
That's a 50-50 cost share for essentially a $400 million facility. That'll be one project. These are big industrial scale projects, which is why getting private financing. The government is really just going to be helping pay a portion of the very first projects until we can get the private sector, which is much more risk averse, to start funding these projects. That's where we're so grateful to have Brookfield Renewables with us, trying to support us and support industry making this transition, because that transition is hard, it's lengthy, and it's really expensive. But people are spending money all the time on things. We're just trying to change the nature of those expenditures so that they are truly sustainable, and that we're not continuing to plow money into technologies and supply chains that cause harm to the planet.
Yeah, no, that's I've got about 82 more questions, but we don't have that much time, and that's I think why you and I get along so well. Yeah, absolutely. But yeah, as you were talking about the SAF and the ethanol utilization in there, that's where I was thinking was, when we produce corn ethanol, we're producing a tremendous amount of CO2 as well. So you're displayed by you using an already off gas from another process to produce that ethanol. We're eliminating some of the need for all this corn growth and some of the farmland and things like that. But then to add into that even off of a standard existing corn or sugarcane ethanol plant today, you can capture that CO2 and just make more of it and make more of the same that you're already doing. I mean, that's outstanding. Yeah, absolutely. So many opportunities in all this. And again, just to be clear, I'm not against direct air capture and DAC, but DAC is a means to an end to take CO2 and put it into the ground today. But it's the utilization, what else can we do with this CO2 and keep finding more uses for CO2. That's how we're going to ultimately solve this problem, and not just capture, put in the ground, and keep paying for that process.
And if I could, quick shout out to DAC. I mean, we also envision DAC as a long-term technology that could become our feedstock, because at the end of the day, these industries that we're trying to help transition, we're not trying to lock them in forever. We're not saying steel should be using raw carbon from coal and coke, et cetera. But until that industry can reach equilibrium, until it can move on to available, affordable, low carbon hydrogen, for example, or to direct electrolysis, which is probably even further along, or farther in the future. But until we can do that, those emissions are just going to the atmosphere. And like you said, you can get those at higher concentrations rather than going at just over 400 parts per million from the atmosphere. But later, as some of those wastes go away, we'll actually be able to use that direct air capture as our feedstock. I think the issue is, what can we do today at the best efficiencies, getting the most value, and transition over time? Because none of this happens quickly, and the technology development to even get to those technologies is going to take time, usually measured in decades. And in a lot of cases, we actually don't have decades, so we have to be doing all of it all the time. And so I just think we fit really well into this transition, taking advantage of those available feedstocks today, but then transitioning with technology over time to take advantage of the waste products of the future to what we hope to envision is a zero waste sort of environment where everything is just recycled the same way nature recycles. And that's why we're using biology.
I think that's what's most fascinating. It's you're taking a natural course with a lot of these things. Well, so I'm going to close on this. it's those that want to just go from zero to the end game, it won't happen. So we can't just get off fossil fuels. We can't have 100% green hydrogen today. And I think you kind of really hit on it. The solution is all of the above. We have to find alternative sources and alternative uses and things like that. So there's the legislation in front of Congress today, which I'm sure, as you being up there, are very involved in. But the Parity Act, just to make in the Inflation Reduction Act that tax credit for sequestration $85 a ton, but for utilization $60 a ton, you should be getting $85 a ton. Maybe you should be getting $125 a ton instead of just you should be getting more. But because you're taking a problem and coming up with a solution that can ultimately wean us off these things. Wean us off. Wow, that was hard to say. Wean us off these things long term. And so great stuff.
Thank you. Thanks for mentioning that. Yeah, the CCU Parity Act. We would love to see that passed and get us at least to parity with fossil fuels and with carbon capture and sequestration, which we're fully supportive of, because we do believe that we need all of these solutions. And the question is, how do they work together? But yeah, we're putting a manufacturing process on the back end of capturing carbon, right? We're not just compressing it and moving it and storing it underground. We're actually doing something to it to convert that into something else. And that comes with additional cost, additional CapEx, those sorts of things. So we really do hope Congress will, when they get around to moving some kind of tax legislation, we're hopeful they'll pass that as well.
And if our audience does want to get involved, help out, opportunity, brainstorm with you, where can we reach LanzaTech? Where can people find you and your team to really get plugged in?
Yeah, please check out our website, of course, LanzaTech.com. But people are welcome to contact me directly. It's Tom.Dower, DOWER, at LanzaTech.com.
Fantastic.
Perfect.
Tom, thanks for coming on.
Great to see you again.
Fantastic. Yeah, great episode. We appreciate you. Best of luck with LanzaTech. We'll catch up soon.
Sounds great. Thanks so much.